to PTMF Push to Main Fridays. My name is Björn. Before we get started, we are going to say a huge thank you to all of our sponsors. They are doing God's work. They are the reason we are here doing all of this fun stuff. I, for one, have been missing this so much, so it's like, yeah, thank you so much to all our sponsors. Here's some random shit about me. I do stuff, I code stuff, I write stuff. I mostly do DevOps stuff in my day-to-day work, but I do other stuff as well. Before we get started, PTMF, what is this? Like, what's it all about? Well, this is the, sorry, I need to read this one. This is the Flowball SUS 316L model PTMF0102 threaded fitting male-female adapter socket. That's not what we're going to talk about today, but it's the first hit if you search for PTMF on Google. Roughly translated from Japanese. PTMF started out as an internal joke at my work. We started, someone had built something, it was a Friday, and was like, let's wait until Monday before we deploy it. And we went, nah, you know, why wait till Monday? Just push the main, push the main. No one remembers a coward, right? Everyone wants to just do their shit. And, you know, this joke started growing. It went, kind of became a regular thing. Every Friday was like, it's Friday, let's push the main, let's do some dumb shit today. But it actually got me thinking a bit, like, how come we get taught that we are not supposed to deploy on Fridays? Why can't we deploy on Fridays? Like, what's the difference between us and the crews we read about or the companies we read about that do 1 million deploys per day? Something they must be doing that we are not, because they can deploy on Fridays. So it's like, do we really write code that bad? Well, I don't think so. Most of the people here should be, or are really, really good at writing code, right? Is it lack of feedback from our systems? Probably. Honestly, I have no idea. I've never worked at a company that does 1 million deploys. But I think I have a kind of idea, at least, where to get started with this. Like I said, we need quick feedback from our changes. Are we working towards the correct goals? Are we doing what the company wants us to do? Is the result what we want? Is the result what we expect to do? We need quick feedback, because if we get too slow feedback, that's why we can't deploy on Fridays and we have to show up on Saturday. That's a slow feedback. We need feedback right away. And we need to be able to trust our production lines. Given all the known knowns, everything we know, it should be as good as possible. There will always be unknown stuff, but given what we know. And if anything bad is added, on purpose or by accident, we need some kind of braking system, something that stops everything from happening. So, with this in mind, we started, we can start to look at the good stuff, right? Nope, apparently we can't. There we go, thank you. Now, when we need to build a stable pipeline, we of course need to start with Git, our versioning tool. There was a great short presentation, I think, I can't remember the name right now. Someone did in the hall outside about Git, how to get started with it. Barbara, thank you. Now, when you start, there's like 1 million different strategies of using Git. You have your Git flow and your GitHub flow, or your trunk-based development. It all comes down to how mature your team is, how ready you are to start working with versioning properly. But there is an expression that the Azure API developers use that I heard it and I immediately fell in love with it. It's called live at head. So one branch, no matter which strategy you use, should always be live. That's the one you're working with. That's the one you're working towards. And that's the one that we need to have a stable pipeline that runs on. Keep one branch in a deployable state at all times. It should always be able to run. But I'm alone on stage, and setting this up requires me to do pull requests and a lot of other stuff when I add code, so I'm not going to do it. I'm just going to show it. If I can just copy the link. There we go. Nope, there we don't go. See, this is what I mean. I always mess up my presentations technically. You should absolutely set this up. At least have reviewers on your code, someone to look at it and someone to approve it and so on. You should. I won't, because it will mess up my demos later. There are absolutely way more, and I would love to talk about Git strategies all day. Might even do a session on it one day, but as of today, just pick one branch, make it stable, right? See if we can do this. Exciting. Fantastic. Okay. Bit of tech. There we go. So, once you have done this, you have pushed all your code, it's time to set up a CI/CD pipeline, the reason why we're here today. Now, we are all PowerShell nerds, right? And so we fill our code, our repos with PowerShell code, apart from, of course, Ben, who prefers VB script over everything else. So as for if Ben is here today or if not, just so you know, Ben, the same basic rules applies to just about any and every language that you write. It doesn't matter if it's VB script. It will suck if it's VB script, but it doesn't matter. The same basic rule applies anyway. Now, the first thing we need to do is, of course, create the starter pipeline. You could just upload a YAML file and point to it, but that's not what we're going to do today. We're going to create a pipeline for real. So let's go into our demo repo. Here we have our basic repo. No, here we don't have our basic repo. Here we have our basic repo with some code. Again, Ben, Visual Basic works as well. There are a couple of ways of setting up a default pipeline in Azure DevOps. You could either click the Setup Build button up there, or we can go to the internet. Thank you, internet. Like I said, the tech gods, they hate me. I'm a really, really shitty technician. There we go. Or we can go to the pipelines and create our first pipeline. Now, like I said, you could, of course, upload your own YAML file, but what's actually happening when we're doing this is we're setting up a pipeline definition that is a pointer to the very pipeline that we want to run. We need to select a repository where our code is, where our code lives. In this case, I only have one repository, so it's not that much to choose from. And we create a starter pipeline in this case. There are a number of different pipelines in Azure DevOps. You have your YAML pipelines, and you have your classic pipelines, and you have your releases pipelines that we have a button for somewhere over there. If you have some legacy stuff, absolutely use whatever it is you want. If you are getting started, use YAML pipelines. The other stuff is old, deprecated. It's weird. It's GUI stuff. We don't like GUI stuff. GUI stuff is hard to move around. So we're going to work strictly with YAML today. When we create a starter pipeline, we get our default steps. Pipeline is just a definition of steps. Do this, do this, do this, do this. Everything is in a job or more jobs. The default design gives us a couple of demo steps. We're just going to remove them because we want to build some stable stuff, right? We're back to this again. I was promised that if you had one duplicate screen, it would do this magically, but it won't for me. And yeah. So we have a basic pipeline. We have some basic tasks that we just removed because they are unnecessary. Let's fill it up with some interesting stuff instead. We do not want code that looks like this. Right? Just as you have your Git standards, you have your way of developing, your way of interacting with your colleagues, we have our sort of standards, how code should look, how code should be. We don't want to use aliases, like ls. And above all, if you put your brackets like this, you are a terrible person, and you should be punched in the face. No, we can't have this. We need to have standards like, where are our brackets? We also have standards like, you probably shouldn't have passwords in clear text, and you shouldn't hardcode your DNS names, and so on and so forth. This is where the linter comes in, the first step to being stable. A linter is, to put it short, a tool to make sure your code lives up to your rules and standards and the community rules and standards. When you write code, if you use Visual Studio Code today and write PowerShell code, you have already seen it in work. It's the little thing that makes twigglies under your errors. Most linters also allows you to define custom rules, say what they should do. You can also exclude rules and say that I don't care about this. In PowerShell, our linter is called PSConfEU. Oh, I should have, what? This is where I should have said. This is what we want our code to look like. Brackets on the correct line, not like some madman. In PowerShell, like I said, our linter is called PSConfEU, and it's run automatically when we write code in VS Code. But of course, we also want it to run when we have code committed to a repo, so we can make sure that no one pushes bad brackets to our code. Come on. Thank you. So, let's add some steps to our pipeline. There are more than two, but two basic ways of creating or writing a pipeline. You can use the built-in editor like this, or you can use Visual Studio Code. Just clone your repo. It creates a YAML file if you're in your repo. If you don't have one, you can just clone it down and edit it. There's a brilliant plugin in Visual Studio Code you can use. But for simplicity and less use or less time taken to push and pull and move around code, I'm just going to use the built-in one. We also have quite a neat little feature in this built-in editor, that is the assistant. This one lets us search through steps, different things we can do in a pipeline. We can add stuff, we can add new steps, we can create our own steps. There was a brilliant session the other day, again, I'm terrible with names, on how to create these steps, how to add more stuff to it. But for our pipeline, we're basically just going to run a lot of PowerShell. And there's a built-in step already for PowerShell. It's quite simple. Just input what you want to do. We are going to run script analyzer using the invoke script analyzer commandlet. It's built in PowerShell. Oh, sorry. We have our magic variables. These stems from Azure DevOps by itself. That tells us start in this directory. This is directory where all our Git code is checked out. Do a recursive search. And in my case, even though I think you're a madman if you put your brackets on the wrong line, I only actually care about the most severe errors. The reason for this is that severe errors is such things as clear text passwords. I don't want them in my code. Or actually, I do not want you to handle passwords in clear text more correctly. There's also a flag for it, a switch that says enable exit, which simply says break if something happens. So if someone pushes code to my repo that requires clear text passwords, this will turn red. There's also a couple of other things. We can, of course, set our preference variables, error action and warning action and so on. Verbose preference, I'll just leave those to default for now. One thing we need to check is this one. Fail on standard error. Sorry, I've got the hiccups. This basically tells our pipeline that if something goes wrong, you should break. You should stop. All the time. And because we are modern people, we should also check the PowerShell core, of course, because PowerShell 7, it's not named PowerShell core, but Azure DevOps is super fast in changing their standards. One quirk with this editor, though, you have to keep track of where your cursor is, because it will inject code exactly where you are. So if you're here, it will just, yeah. And then we just do add. Simple as that. We are running our script analyzer in our code. And yep, it looks quite good actually, I think. We could of course also give it a display name to make it look better by just doing display name run PS script analyzer like this. Okay.
So PowerShell at 2 doesn't mean version 2?
It's version 2 of this task. It actually doesn't, it's just a definition. It's called, every task has a name and a version. If the version is version 2, I don't know really, I haven't kept track of how many they made in between, but yeah. Every task has a name and a version.
I think it's PowerShell stuff.
Yeah, I'm just reading.
Yeah, you should always just go with the latest. And that's why I don't keep track of versions, I just use whatever it gives me.
Version 1, you didn't have the ability to run inline script.
Ah, awesome. I did not know that.
You couldn't launch files.
Nice. Or not nice. I did not know that. Thank you very much. Okay, so we have at least got started. We have injected some script analyzer into our code. We verified it lives up to our standards and the community standards and so on and so forth. It's time to verify that we have code that works as we expect. Now, no matter if you write PowerShell like we do, we have Pester, or if you write infrastructure as code using Bicep, or if you write your modules in C#, there are testing frameworks for anything and everything. And code that doesn't work, well, it's no good. In fact, I would say it's probably the most important step in this entire presentation. So like I said, you have testing frameworks for just about any language. You have your what-ifs for ARM deployments for Azure. You have NUnit or MS-Test for C#. And yeah, like I said, Pester for PowerShell. Sorry, Ben, I have no idea about testing frameworks for Visual Basic. The important thing is that you write tests. There are also a number of different types of tests, and I would absolutely love to talk about all of them, because this is something I really, really enjoy doing. But we don't have that much time, so instead I'm just going to say, start writing unit tests. If you don't already know what a unit test is, it's basically a test that tests a small one batch of work, one function, one line, not the entire flow, mocking away such things as databases, APIs, and so on. In fact, I would go as far to say the CD part of a CD pipeline has so many definitions, and no matter if you call it continuous deployment, or continuous distribution, or continuous delivery, the testing is the most important part of a CD pipeline. I'm also going to add some improvement steps to this. The CI, some people refer to it as continuous improvement. How many times have I not heard, oh, we don't have time to write tests? Or, I don't know where to start, there's so much code, I have so much legacy, like it's impossible, this is just a monolith, it's terrible to work with. Or, my absolute favorite, I already know my code works. Yeah, you don't, or you think, but it doesn't. It never works. Nothing ever works. But I'm going to toss in a few recommendations on how to get started here. The next time you find or receive a bug report, no matter what it is, replicate it. Write a Pester test that does what crashes your system, what went wrong. Or the next time you want to add something new to your monolith, just write a tiny little test saying, if I do this, then this would happen. And then the next time you get another bug report, write a tiny little test one. This way, I can swear to God, in a very short time, you have a pretty good test coverage. It's actually quite, I'm going to say easy, I hate the word, but it's not that hard to get started. And we tend to over-engineer everything we do. We say, I need to write tests for every single function. You don't have to do that. Just write a tiny little test to start with. If you do this, You are slowly increasing your test coverage. You're verifying that you don't get the same bug twice. This bug will never come back if I have a test for it. And now you can also trust that every single PR from your colleagues or friends or community members, they won't reintroduce the same bug. Even if you have a monolith of millions of other bugs, at least this tiny bug will never come back. So just get started writing tests, okay? Now, I also need you to remember one thing. If you don't write your tests, well, Jakob is watching you. He will be mad. And if you need help writing tests, I mean, I will absolutely help you. Not in this session, but somewhere. Or you could probably ask him, because he's the god of test frameworks. But a test is no good if it's not run. So we're going to add it to our pipeline as well. Of course, switching screen. There we go. Well, that was unexpected. There we go. Just like before, we're going to run this in PowerShell. The default Ubuntu runner has PowerShell on it. It has Pester in it, and so on. So there's not much we're going to do. We're going to add a PowerShell step. Like this. I'm going to do an inline script. And just like you said, you could also do it in a file. Totally up to you. I prefer to do this way because it's simple to read, and as long as it's short scripts, I prefer it. There's a couple of things when we run Pester in a pipeline. Again, we need to give it the path to our tests, of course. I have a super advanced structure of one test file in my base folder, so yeah. I always want to add this because it's human readable. This gives us some feedback in our pipeline right away that we can read. But above all, when you run Pester in a CI/CD pipeline, we need to add the -ci flag. This one makes Pester output a XML file that is not human readable, but is a standardized way of showing test results in our pipeline. We will get back to how this looks very, very soon. Again, we're of course going to use PowerShell core, but we are not going to fail this one on standard error. Now why? Well, because we're actually going to do this later. There are some things we want to add in our pipeline outside of this. First of all, we're going to give it a good display name. Thank you. Run Pester tests like this. There is a built-in task that we have called publish test results. Oh, thank you. It looks like this, and we can give this one a couple of parameters, or such as which test result format this is in. Like I said, if you run Pester with a CI flag, it will output a XML file, and this XML file is in the NUnit format default. NUnit is a super standardized way of displaying test results. This can be included in just about any languages, or any pipeline runner you want to. Like I said, I work in Azure DevOps, but if you are running it in Jenkins or whatever, they can probably read the same test results. We need to give it a search path to our test result files. Now, I can't remember all of these parameters per default, so of course I am going to cheat and just take my done like this. Thank you. There we go. Where do I have my wrong? Somewhere there's a wrong. Let's just do it like this then. Copy this one, put it there, and we should do this. We can remove it. There we go. Yeah, the default format, you have to have the output. This is well documented in the Pester documentation, but I can never remember it by heart. But it gives us some beautiful test results. And also, here we have the fail if there are test failures. So this is the place we actually want to fail our pipeline. We always want to see the result. This gives us a really, really beautiful report and some other stuff. We can add it. We can give it a good display name, like this. Publish test results. And we're actually going to add one more thing, and that is we're going to say, I need my cheat code. It's condition. Condition, always. We want this step to be run every single time. This is the one that shows us our test results that we will be able to track through our graphs and so on, and we can give this report to our boss and see, look how good we're doing. And the fact that you allow us to write tests and not just say, new features, new features, new features. This is the graph showing how little problems we have and so on and so forth. But we need to run this task every single time to get the test results there. Every single time. Nope. Okay, good so far.
What does this mean with the run tester tests? Will that not run every single time?
It should run every single time unless the linter has crashed. So it will run one step, and if that step works, it will run the next. And giving this always, I already changed the screen, but giving it the condition always makes it run even if anything before it in the pipeline crashes. This can be good or bad, and you have to keep your tongue kind of right. But yeah, it's a good way of always getting test results. Test results is something. Test result statistics is something that we probably want to see no matter what happens in our pipeline. Okay. We're almost done with our basic pipeline, but I think it's worth at least mentioning some security aspects here as well. After all, like if we're hacked or if we leak stuff, we can't really claim to have a good releasable product. Now, in relations to the pipeline themselves, I should always make sure that we had some security scanning, at least scan for checked-in secrets, because you will check in your password or your strings or your SAS tokens or whatever. They will end up in your repo. It's not a question of if, it's a question of when. So I would say always add at least scan for secrets somewhere. Now, scanning for secrets is a best effort. It's regex patterns, it's terrible to read, and it will give you false positives every now and then, but I would still say that 1 million false positives is way better than 1 leaked password. I would absolutely prefer it. Like I said in my previous session, I'm absolutely not a security person. I hate security, but I want security off my back. So, if there is a password in our source code, or when there is a password in our source code, we should pull the brake. This code shouldn't be deployed, and we need to do a password reset, a full, what it is you're doing. Yep. My daughter calling. Thank you very much. Perfect timing. Yeah, so there are a number of different tools to do security scanning, and I can't mention them all because the list is like kilometers. A good place to start is the OWASP sedated framework. It's on GitHub. There's a link included in my presentation slides that you can download later. It's a really, really good place to find your regex patterns, at least. The problem is, well, I couldn't find one for PowerShell. So, well, bit of humble brag. I wrote my own. And we're going to add it. Now, by now, you already know the drill. First, a bit of technical problems. Then a bit of Björn problems. And then we add a PowerShell task, and I no longer have to tell you how to do this, because we're going to click PowerShell, we're going to do inline, we're going to... Yeah. PS secret scanner is available on the gallery. It scans for secrets using the OWASP standard regex patterns and a couple of extras I found somewhere here and there. I find it really useful. We're going to use PowerShell core, and of course we're going to pull the deadly dead break because we are never going to deploy stuff with passwords. Now, this is actually more evil, bad, terrible than everything else we're doing today. I mean, I would rather deploy something with okay, I would never deploy something with a bracket on the wrong line, but I would rather deploy something with a bracket on the wrong line than something with my password in it. So we're going to add this first. Be gone. Like this. And we're going to give it a display name. Because display names are cool. Right? Like this. Okay. Sorry about this. Eventually, I'm getting my voice back, maybe. Okay, so we have added some password scanning as well. And we can now actually save and run this. What it will do is Azure DevOps will now add this YAML file to my repository. It will save it. It has created the default pipeline definition, and we have created all our steps that we want to have. And hopefully, if demo gods are willing, it should start running stuff. Thank you. Nope. While this is running, I lost my thread. Sorry about that. Let's go back. Let's do this again. So hopefully this will be running green all the way through. It will scan for our passwords. I did include some verbosity to it so we can see which tokens and so on we are scanning for. We are making sure that the script analyzer rules that we require are there. Of course, there's also ways of excluding this, but we are making sure our tests are running. And whenever we get a new bug, we, of course, write a new test. So bug number 666 will never show up again. That was a terrible bug. I got a kiwi instead of a banana. It was terrible, terrible to fix. We are publishing our test results. Like I said, this is the task that we run every single time. And because we do this, we get this neat little test tab shown over here. And if we click this, we get this neat little display here. I would need a somewhat bigger screen to show it in its complete, but it gives us some statistics. It shows us how many tasks have failed and passed and how many have failed and so on. And if we would have some failed, it would give us a nice little graph down here that shows this is how many you have failed. It also lets the bosses and the managers, they can set up a dashboard like this showing how good the test coverage is and how little failures we have and how quick everything works and how good it is to write tests. This is all because of the whole publish tests thingy that we did. So let's go back to our presentation. There we go. Thank you. And there we have it. What I consider are three most important pillars in the place for a good, stable CI/CD pipeline. We have our code strategies using Git. We have our code standards using our linter, making sure that everyone writes code the way I want code to be written and not like a maniac with their brackets on the wrong line. And we have our code integrity by running tests, by making sure it works, by making sure that no one includes passwords in their code. And together, this gives me immediate feedback about my code. It makes sure that nothing breaks. And since I know it will break, if something goes wrong, at least something I know that can go wrong. Everything I know about is in there. And since it breaks if something goes wrong, I know that I can trust my production line to work as good as it possibly can. Now, of course, there are several more steps you need to add to your pipelines. You need to compile your code, you need to build your modules, you need to deploy to wherever you're deploying, but yeah. And you probably should add like SAST and DAST tools, and if you're curious about those, meet me up afterwards and we can talk about it. That's like scanning for even more worse code problems. You probably should set up environments to protect your resources. Gates. We need more people to look at our code every here and there to make sure that it's okay. If you have a cab board, they love to have a big red button that says, no, only I can deploy. I'm most important. But all of those, I would argue, are improvements. They're not necessary to get over the hurdle. This is what I need to get over my hurdle. I can still push to the PowerShell gallery from my own computer, as long as I know the code works. My point is, if you have these steps in place, and keep improving your tests, keep improving your workflows, then you are on your way to have a deployment flow that you can trust enough to release any and every day of the week, with an ever-decreasing number of issues and an ever-decreasing amount of manual interaction. Or, to put it another way, if you have these steps in place, you are quite ready to push to main. Come on a Friday. You're ready to start doing PTMF deploys. I can go home every Friday evening knowing that even if I push stuff to my main branch, to my stable, to the one that's live, everything I know works. Of course, stuff I don't know. But stuff I don't know, I learn. And I write tests for. And I can keep doing it. And with that, we have 6 minutes and 50 seconds for questions. Thanking you very much. This warms my heart. I am now officially collapsing. Yes!
Do you really push to main on Fridays because of the unknown stuff?
Absolutely.
Okay.
Because, like I said, getting started, the first months, weeks, years, depending on how big your code base is, you will mess up. But if you just keep doing this procedure, keep adding tests, keep adding stabilities, keep adding, like, whenever, just don't firefight. Instead of firefighting, take an extra couple of minutes to do this. And it's actually scary how fast it goes to get a decent test coverage, because most problems, they will show up quite quickly. So yes, I do push to main on Fridays nowadays. I release whenever and wherever I want. Unfortunately, I am also a consultant, so I don't really do work on weekends. That's someone else's problem. Any more questions? Everyone is crystal clear on what I think is useful to do. Emmanuel.
What would you say is a good extra step when you kind of set up your theme colors? What would you do from there?
I would do SAST, first of all. Static code analyzing. Or it depends mostly on the language, actually. If we're doing PowerShell, the next step here is to build a decent build script, I think. Like use invoke build or similar to build a build script that does all your release management for you and your combination, because we do not want that stuff to mess up as well. Sorry. So standard development in PowerShell, we write our modules, and we have each and every function in a file named after that function. We have our standard setup of internal or public and private, and we have our classes and so on. And you can go about and combine and rearrange and write your module manifest and update your versions and so on and so forth manually. That's doable. I've done it a million times. or you write a script to do it for you. That way, we have stability in the actual release as well. We trust that our build script do the heavy lifting. We know that our module combined will also do the heavy lifting for us. And in the same time, I would also say, add another step to run tests after on your built module. So run the same pester tests before you build your module to know that everything worked as it is. Build your module and run the same set of pester tests on your built module to make sure it still works. Because shit happens when you rebuild stuff. So I would probably say in PowerShell, go for a build script. If you're running C#, for example, C# is quite easy, just to run the build step task thingy. I'm not a C# developer, as you might hear. But then I would go into more security scanning, SAST and DAST steps. EAST, which is the final of the 3 big security scanning steps, it's fun, doable, but not necessary. Good answer? Thank you. Any more questions? We still have Jonas.
What do you do with dev tests and production environments? Do you have some? What I'm trying to ask is, in our dev environment, we want the pipeline to run very fast.
Yeah.
It becomes tedious to wait for all of this.
Yeah, that's when filtering and the amount or the types of tests comes into case. That's why I said start with unit tests. A unit test should, by definition, be very small and very fast. Test the shortest path to travel. And those, I mean, we can't get over the fact that some stuff takes time to run. And I think you should run as much as possible on every single dev test prod stage. But we probably don't need to run integration tests, for example. The one that tests our entire code paths. Those tests we can save for staging or test environments instead. So you can add tags to pester tests, and you can say, instead of like I did, just run everything flat out, right, every single time, you can say, in this environment, just run the one tagged with super fast. In this environment, just run everything. Because like you need to run everything eventually, of course. As for environment-wise, you can absolutely set up steps and add more jobs and say, deploy to this, and for example, you do your dev environment, deploy to this every single time. Every time I push into my main branch or a side branch or whatever, deploy to my dev environment. If that goes well, just move the pipeline on and run our internal tests for bigger test frameworks or for everything that takes time. Run that test framework. If that goes well, publish an artifact, and then we can use that artifact into our production environment. So we shouldn't, it's basically build once, run many times, but it quickly gets a bit of spaghetti-o, and I would love to do it, but I have 48 seconds left to talk about it, so yeah. I can show you some super secret stuff afterwards that we can look at how we solve this. One more question. 34, 3, 2, 1, 0. Okay. Thank you very much. I hope you got some good information for it.